In this video, we're going to understand differentiation. But before giving you the actual definition, I want you to understand some of the terms that are related with it. Let's say we want to find a tangent of a curve y is equal to f of x. What do you understand about the tangent line? A tangent line is a line which locally touches a curve at only one point. Any increase or decrease in slope will result in intersection of curve and line at 2 points, which won't be called a tangent line. We know that the slope-intercept formula for a line is y is equal to mx plus c, where m is the slope of line and c is y-intercept. For this problem, we're gonna take a function y is equal to x squared. And here we have been given a curve. You can see this. This is a curve. And let's suppose you're taking any point. For this, we're gonna take point 1 and 1, 1 comma 1. I have taken this point 1 comma 1. And let's suppose you want to find equation of tangent line. This is a tangent line because it only touches the curve at one point, and you want to find equation of this. But we know to find equation of tangent line, we will need 2 points or 1 point and a slope. This is the condition to find a tangent line. Now, what we can do is, we will take an arbitrary point over here, and we will take an arbitrary point on this curve. We know that any point on this line will be, for example, x. The second one will be x squared, because we know from this above graph that y is square of x. If it will be x, the second will be x squared. Okay. First, let's see the graph for this. What we are going to do. Let's say we bring this point closer and closer to that of point 1 comma 1. In the second graph, you can see we're bringing it closer. Then in third graph, we can see it's coming much closer than previous one. In the fourth graph, we can see it's coming much closer and closer and closer to that point 1 comma 1. And we can observe that, we can see that first it was a secant line. By the end of this, in the fourth graph, you can see when the point comes closer and closer to that of point 1 comma 1, the secant line is approaching to that of a tangent line. You can see here in the first graph, it's touching the curve at 2 points. Then in the second one, it's touching the curve at 2 points. Then in third, it's touching the curve at 2 points. But in the fourth, it's almost approaching the graph at only 1 point. That means the more you bring closer the values of x comma x squared, the more secant line is approaching to that of a tangent line. Now we know the formula for slope of a line, that is equal to rise over run, or y2 minus y1 divided by x2 minus x1. This is a general formula. For example, you're going to take a line. This is point x1, y1, and this is point x2, y2. And if you want to find slope, that is change in x coordinates, that is, sorry, change in y coordinates, that is y2 minus y1 divided by change in x coordinates, x2 minus x1. But for here, we know the line has 2 points. That is, one is a fixed point, that is 1, 1. The second one is arbitrary, a variable point, that is, this is a variable point. Okay, this is a variable point which is x comma x square. Okay, now if you want to find slope for this line, we know that slope will be equal to change in y coordinates. Y coordinates is this minus this, that is x square minus 1 divided by change in x coordinates, this minus this, x minus 1. Now you can simplify it. We know that it is x square minus, we can write it as 1 square. We know that if it is a square minus b square, it can be written as a plus b and a minus b. That is x minus 1, x plus 1 divided by x minus 1. We can cancel this and this. That means the general formula for slope will be equal to x plus 1. Okay, this is the general formula. Now what if we take the x value as 2? That means, let's suppose this point is 2 comma 4, for example, and later what we are going to do is we're coming closer and closer to the right, from the right side to the point 1 comma 1. Okay, let's suppose the first point is 2. That times the slope will be 2 plus 1, that will be equal to 3. Okay, let's suppose you're approaching to the point 1 comma 1 from right side. First it was 2. Okay, the coordinates of x was 2. Now it will be, if you're coming closer from right side, it will be 1.5. That times the slope will be 1.5 plus 1, 2. And you're approaching from right side and coming closer to 1. Okay, first it was 2, then 1.5, then it will be 1.1. The slope will be 1.1 plus 1, that will be equal to 2.1. The more closer you're approaching from right side, okay, the better approximation you are getting for slope. Here we can see that if you are taking the value 1.001, that times the slope will be equal to 2.001, or we can approximate as 2. Okay, now in the first part we're approaching 1 comma 1 from right side. Let me read right. Let's suppose this was a point. You're approaching this point from right side. First it was here, then you're coming closer, then here, then here, then here, coming closer. But in the second part, what we need to do is we will approach to the value of 1 and 1 from left side. First from here, then we will coming here, then here. Okay, we know that we have already found the general formula for slope is x plus 1. Okay, now for example, you're coming to this point, its coordinates or x coordinate will be 0. So that time the slope will be 0 plus 1 and it will be equal to 1. 1 is the slope. If you're coming from right side, now the x coordinate will be, for example, 0 0.5 plus 1. The slope will be equal to 1.5. And the more closer you're coming to the 1, the better approximation you are getting for the slope. Okay, the more closer you're coming from 0 to 0 0.5, then 0 0.9, then 0 0.99, and the more closer you're coming to the point 1, the better approximation. Here we can see that the slope approached to 1.99, or if we approximate it, it will be equal to 2. Okay, now our main objective was to find equation of tangent line. We know that we had taken a journal point one comma 1. So the slope will be equal to, we know y is equal to mx plus c. Okay, the y coordinate is 1, the slope being 2, because we have found it from these two tables, and x is also the 1. We can find the intercept, it will be equal to -1. So the general formula for equation of line with y is equal to slope being 2 into x and intercept being 1. So we have done. But you must understand that by doing this, we have done something which we called as differentiation. Okay, differentiation. By coming closer to that of a point 1 comma 1, we have done something which we called as differentiation. The derivative can be interrupted as a slope or a gradient of a curve at a particular point. It represents the instantaneous rate of change of a function. Or we can say it describes precisely how fast is function changing at a particular point. Simply, if I talk about derivative, it is just that it helps us to analyze how much there is a change in output when we slightly nudge the input value. Thank you.